Drawing a line freehand is a creative choice, but defining that same line with a pair of numbers transforms the paper into a measurable system. Today, we are following the instructions for CBSE Class 9 Mathematics Activity 12, Finding a Hidden Picture. To complete this activity, you will need graph paper, a sharp pencil, a standard ruler, and an eraser. We are going to take a series of coordinates and place them on the page by at the end. You will see how these specific locations join together to create a complex shape. First, build your framework. Use a ruler to draw two straight lines that intersect at a right angle in the middle of your graph paper. Identify the horizontal line as the x-axis and the vertical line as the y-axis. The exact spot where these two lines cross is our starting point, is the origin, and its coordinates value is 0 on both the x and y axis. Mark your grid lines outward from that center point. Going right and up, count from 1 to 10. Going left and down, count from -1 to -10. Now we have a Cartesian plane. Every location on this grid is defined by an ordered pair written as x, y. The first number, the abscissa, shows the horizontal position. The second number, the ordinate, shows the vertical position. These axes divide our paper into 4 quadrants. In the first quadrant, both coordinates are positive. Moving counterclockwise in the second quadrant, x is negative and y is positive. The third quadrant is entirely negative. The fourth quadrant has x positive and y negative. Let's plot the first point in our sequence, point capital A, whose coordinates are 2 and 9. Start at the origin, move 2 units to the right, then count 9 units up. Mark that spot. It is important to remember the order. If you move up 2 and then write 9, you end up in the wrong position. Always find your x value first, then your y. For a coordinate with a negative value like point B -5, 4, start back at the origin. Move 5 units to the left, then 4 units up and drop your marker. Once you establish this rhythm, you can work through the entire list of points. Check off each coordinate as you mark its specific address on the plane. Each dot represents a fixed location in space. By themselves, they are just data points, but together they form the outline of our subject. Now that the points are plotted, use your ruler to connect them. Draw a straight line from point A to point B, then from point B to point C, continuing in alphabetical order. As the lines link the points in the correct sequence, the scattered dots form a recognizable shape. If you skip a point or connect them out of order, you lose the intended form. If the aircraft looks correct, it confirms that your measurements were accurate. We started with a blank grid and a list of numbers, and we ended up with a technical drawing of a biplane. This same logic allows navigators to chart safe paths across the ocean. By plotting depths and coastlines on a grid, they create a reliable guide for travel. Handheld GPS devices use these same principles. They calculate a digital path by connecting coordinate waypoints to show your exact position and movement. The shape of the actual aircraft perfectly matches our drawing because its dimensions are based on these same geometric relationships. Coordinate geometry provides a standard way to record the position of any point in a space. It is a fundamental tool for mapping the physical world using nothing more than a list of points. So, now you know that coordinate geometry isn't just a chapter in your textbook, it's the mathematics behind GPS, digital maps, navigation, and modern surveying. Every location on Earth can be represented using coordinates, making coordinate geometry one of the most practical and powerful branches of mathematics. Keep learning, keep exploring, and I will see you in the next lesson. Thank you.